Random Trivia with Spartan Taco. Today's episode, Types of Planets. Now, when talking about planets to determine what type they are, there are three main things we have to consider: mass, orbit, and chemical composition. Now, for the sake of this video, I'll only be going over composition of planets since mass and orbit are pretty self-explained. Mass going over how big or small a planet is, usually getting the name super, mega, or mini added to the planet. And orbit is just the distance it is away from its star, or in some cases, its neighboring planet. Now onto the planets themselves. The first type of planet is a Chthonian planet. These planets are in most cases expected to be gas giants that have had their atmosphere stripped away, leaving their cores behind. Now the best example of what this means is if you were to take, let's say, Jupiter and put it much closer to the sun. Over time, in a couple million or even billions of years, all the gas will be ripped away, leaving behind its core, thus a Chthonian planet. Next is a carbon planet, a theoretical terrestrial planet which are carbon-rich and oxygen-poor. Now, without getting to percentages of carbon, oxygen, and others, the main thing you need to know on why carbon planets are different is, unlike most terrestrial planets, which are composed mainly of silicon and oxygen compounds, carbon planets are much more carbon to oxygen, carbon being much higher. Next planet is a coreless planet. Now these planets are pretty self-explained. They are a planet due to some reason has no metallic core, which would most likely cause the planet not to have any magnetic field. These planets will most likely have cooled very far from its star. Next planet is a desert planet. Also pretty self-explained, a planet that would have the same level of consistency of desert, much like you would see on Earth. The best example of this would be Mars. Next is a gas planet, are pretty easy to understand. They're primarily of hydrogen and helium, two of the most common elements in the universe. Now, in some cases, they can actually be considered failed stars depending on their mass, much like Jupiter. Next is a helium planet. Much like a regular gas planet, helium-based planet is more helium rather than hydrogen. There are a few theories on how a planet like this is formed, but the most accepted one is via hydrogen evaporation. Pretty much depends on the star and how hot the planet can become to burn out the hydrogen. Hot Neptunes are considered the best candidate for such type planets. Next is a Hycean planet. Is a hypothetical type of exoplanet that features a liquid water ocean underneath a hydrogen-rich atmosphere. Hycean planets are thought to be common around red dwarf stars, and are considered to be a promising place to search for life beyond Earth. Next is an ice giant, not to be confused with ice planet. An ice giant is composed mainly of ice volatile substances, heavier than hydrogen and helium, such as oxygen, carbon, nitrogen, and sulfur, as opposed to gas. Best examples of this would be Neptune and Uranus. Next is an ice planet, not to be confused with ice giant. It's pretty self-explained. It's a frozen world composed mainly of water, methane, and ammonia. Next is an iron planet, which is a planet that consists primarily of an iron-rich core with little or no mantle. The best example of this would be Mercury. I'm sure you're wondering, what does it mean to have little or no mantle? Well, unlike Earth, where we have tectonic plates, an iron planet would just have one mantle, which is not as good as it sounds. Let's just say earthquakes and volcanoes will be very common. Next is a lava planet. Is a theoretical terrestrial planet with the surface mostly or entirely covered by molten lava. Now, the interesting thing of note of a lava planet is that a lava planet would indicate a young planet, and in a million-ish years after it's cooled off, it could have a chance to become potentially just like Earth. Next is an ocean planet. Is a theoretical planet that has a substantial fraction of its mass made of water. Similar to a Hycean planet, the only difference is that an ocean planet doesn't necessarily have to be water. It could be made up of other chemicals, much like ammonia. Next is a protoplanet. Is a large planetary embryo that originates within a protoplanetary disk. Now, I'm sure if that sentence you have no idea what that means. To easily summarize, is for a planet to form, they are made in planetary disks, or protoplanetary disks, which are pretty much large fields of rocks, not necessarily asteroid fields, but very close. And over time, they all collide together, getting bigger and bigger. A protoplanet is essentially a baby planet. Next is a puffy planet. Is a gas giant which is with a large radius and a very low density, which is similar or lower to Saturn's. Pretty much a gas planet that is much fluffier than the rest. Next is a silicate planet. Is a terrestrial planet that is composed primarily of silicate rocks. All 4 inner planets in the solar system are silicon-based, which would include Mercury, Venus, Earth, and Mars. And last, terrestrial planet, also known as telluric planet or rocky planet, is a planet that is composed primarily of carbonate or silicate rocks or metals, and is also what Earth is considered. And with that, the list of planets has been read. Now, there will be planets that don't fully fit into the list, which in many cases make us rethink how planets are truly made.